Hello everyone, welcome to today's tutorial Tic Tac Toe Game. So today we're going to be creating a simple but fun game with Python, and that's going to be a Tic Tac Toe game. So, and therefore if you're a beginner, you'll be able to follow along with this game easily and be able to catch up and follow along. Just code along with the program and you'll get things right. Hello everyone. So while building our Tic Tac Toe game here, the first thing we want to do is to set up the board. And what are we going to do? First thing, we want to have a game board, and in this we want to define the grid. Okay, let me just have a comment here and let me say code with streaks. Then okay, now we want to define constants for our rows and columns of the board. So I'm just going to have constants here for the game board dimension. Okay, and we are going to have rows equals to 3. Then we're having columns 2 also set to 3. So right now we're having 3 rows, 3 columns. 3 rows, 3 columns. And now why are we using constants? Constant is just a way that we want to signify that we don't want to change this value. We want it to always be like that. And in Python, when you want to reference a constant, you use capital letter for your variable throughout. That's just capitalize a variable. So we are going to be having our first function here in this program, and this first function is going to be something we call display board. And what is this going to do? This is just going to print out our board and give us with the state of the board itself. So let me just go ahead and write this program so you can know what I'm talking about. So we have display the current game board. So we are displaying the current game board with everything in it. So I'm just going to right here, we want to print here. Okay, I like this to start on a new line. Then I like to use this hash here, then just 3 dash, then hash again, 3 dash, then hash again, 3 dash, then hash again. So that's 4 hash, then 3 dash in between. So for row in board. So I will explain this in a bit now. So let's just code along with this. I'm using this slash here. Okay. Okay. Then we have this now. Dot join str, that's converting this to string, cell, then for cell in row. Then okay, I'll explain this now. The thing is that we want to print out this, and this. But while we're printing out this, and this, these 3 slashes, what we want to do is that in this slash here, we want to join this to it. And this is just joining is in an element, you want to join the list, the elements in that list, you want to join them together to form a string. So that's why you join things together. And what we are having here is an inline code here, and we are looping through the row here. First we loop through this for row in board. So we get the row there. Now we are looping through that row again, and we are getting we are calling it cell, just as we call this row when we are looping through the board. Then we are calling it cell. Now we are returning that cell itself. So we are joining this together now. So let me just okay, let me copy this and print this last. So when I run this now, you will see what I'm talking about. This function is just basically going to display a text-based grid with lines and slots of how the Tic Tac Toe is going to be, and this join function here is going to use to format the row. Okay, this might be new to you if you're a beginner. It takes that join function there takes a list of items and join them together with a separator, and this is the separator it's having now. So we're just going to join the list of items together with this separator. So without further ado, let's just run this and let's see. Okay, let's say let's just try defining a board now. And this board is going to be a list of lists. And what do I mean by that? It means we want to have a list that has a list inside it. and now we can see that we are having something like this. This is how we want the board to look like from scratch. Okay, our board is basically going to be like this, then 7, 8, 9. So if I should format this in a way like this, you notice that okay, this is like a tic-tac-toe grid where we have the row and the column. So if I should like just call this display board function and give it board here, so I could easily run this now and you will see what you are getting here. You will see what you are getting here. So let me remove this new line just to make it look more presentable. So now you see what we are getting here. We are having just this here. You can see it's okay and cool like this. So let me just erase this. Okay, now it's better. Alright, we're having 1, 2, 3, 4, 5, 6, 7, 8 now, and this is just like a grid format. The first thing we do here was to start this in a new line. We print this here because we don't want it to start just from here immediately. That's why we started in a new line. Then now we are looking through this full board itself. Then we are getting each line like this as a row. So this is a row here. So now when we get the row, now what are we doing? We have this here, then we are having this here. Now we are using this as a separator here just to join each element here together. So the first element here is 1, then we use it to separate it from the next element, which is 2, 3. That's the first row. Then through the loop again, we're not talking about the second row here, and we did the same thing for that, the same thing for the third row too. So that's how that works. And at the end of at the end of the print statement here, we have this. We started with this, then we have this. So that's how that works. So now what we want to work on next now is a way to modify this board. So how do we modify this board? So I'll just go ahead and create another function here to modify this board. So I'll call this def modify board. So we have some arguments here, and we have board, we have the slot number. And okay, what do you mean by this slot number? You can see slot number is just like the number here. Like this is a slot, this is a slot, a slot, a slot. So each cell is a slot here. So the slot number is the number we want to have there. Then marker. And what we mean by marker here is just like which marker we put in that slot. Is it X or O? As you know, Tic Tac Toe Game is just represented by X and O's, right? So that's it. So I'll document this function here and just say update the game board. The game board with the players or computer marker. So let's say the player is using X now, and it's the player turn to play. We want to update that slot there with an X. But if it was to be the computer, we want to update that element, that slot there with an O. So what we want to do here now is this slot number, we want to minus equal 1 from it. And the reason why we are doing this, which we will get to know later on, is because when we are working with indexes start from 0, but our slot number will be starting from 1. So with that, to make sure we are working with the right index, we want to like minus 1 from that. So we are going to have two variables here, which is row and column here, and we are going to have diff mode. So we are going to have slot number here, because why we did this is that okay, we start this slot number from 1 and not from 0. So the user is going to be like using this slot number to select where it's picking. So for us to work with the index there, index of the board itself, we need to subtract 1 from there to get the right index. Okay, then columns. Okay, what we just did here is that diff mode is actually going to return 2 values, and this is the result of, okay, it's going to divide this slot number by columns. Then the result will be in the row and the remainder will be in the column. Okay, I will explain this further now. Well, okay, let me just complete this code. And now we have board, row. Okay, we have board, row, and we have column here equals to marker. So we have board, row, and board, column equals to marker there. So let's say if I should just like, okay, do this now, let me write modify board, and I give it the board argument here. Then slot number, I call it 2, so that's this. Now I call it 2. Then okay, the last argument is a marker. Let me put X here, and after that I want to display the board again. So if I should run this now, you can see we get the full board here first, and now when we put X in the marker place, you can see we're having X here instead of 2. So we've modified this second slot number with X and not 2, and now we're getting the display of the board itself again. So this is how slot number work. And now to use this to understand the diff mode itself, what we did here was that, okay, we take the slot number, we divide it by the columns, and we have 3 columns here, right? So 3 divided by, okay, that was 2 divided by 3, so that's automatically 0, but we're having remainder, right? And that remainder is what? Okay, let me just like, okay, let's have a comment here. So okay, let me just do it this way. So we get the slot number here, and okay, the first slot number here now is 2, right? So that's 2 divided by, okay, that's just like, okay, 2 divided by 3, that's equals to 0. Then the second thing we did here was 2 divided by 3. We are getting the remainder, just the remainder now, just the remainder here, and that equals to 2. And now we are having the row as row 0, column 2. This helps us here when we go to row 0, column 2, that is exactly 2. This helps us to like represent the exact position that we are modifying. The exact position we are modifying. That's how that works. Sorry about that, there's a technical error here. I'm opening the code again, mistakenly code my editor. Okay. So as I was saying, so now we have the remainder here. So that's how this works. Okay, let me just view appearance, and let me view my tab again. Let me close this. Okay, so we're back in the game. So that's how we use to get the position here. So let's say now my slot number was slot 10, and if I should divide this by 3 now, I'll be getting back 3. Then if I should like find the remainder of that 3 now, I'll be getting back 1. And what I just did here is that, okay, after I divide this by 3 now, I get back 3. So this is telling me that I want to modify row 3, column 1. And this is row 3 now, column 1 with this now. So we are modifying it now. So if I should just like, okay, let me just, okay, let's modify, let me just copy this now and try modifying with the slot number of 10. So we give this slot number 10 here now. I want to like, okay, let's make this be O. So if you make that to be O like that, we can see, okay, let me display board again one more time after this. Okay, display board now. So if I should run this, okay, row marker list index out of range. Okay. Okay, let me put, oh, we can't use 10, we can just use 8 instead. Yes, 10 is out of range. So we can see I'm modifying this place to be letter O. So what this place is meant to be, if it's 8 divided by 3 now, it's going to be, yes, remainder 2, and 8 divided by, okay, it's going to be 2, then remainder 2 also. Remainder 2 also. And what we did here was now that we get 2, so that's the box row 2 column 2, and this is row 0 1 2. So this is row 2 now, column 2, column 0 column 1 column 2. So if I should just like, okay, let me run this again now. You can see, yes, it's modifying column 8. And that's because this slot number we subtracted 1 from it. So that's how that works actually. So let's move to the next one. And now we want to know the turn of the player who is playing. Is whose turn? Is it the player turn or the computer turn to play? So to undo that now, we want to know, okay, we want to define a function here, and let's just call it player turn. So we'll call this function player turn, and we have board, and we have possible choices. Why are you saying possible choices? Because we want to keep track of the board that you see available to be modified on the game board. So I'll just like document this again, and let me just say undo the player's turn. The player's turn. So I'll do it this way now, and first thing we want to do here is display the board. Okay, now when we display the board, okay, that's the first thing we want to do, display board. And while the game is still running, so we are going to use while true here. While true, we want to use try catch error. Yeah, try catch block here. And the reason we are doing this now is to make sure that, so this is specifically for when the player is about to play. We want to collect the input of where the player wants to play, where the player wants to input his game, and we want to make sure that this input is being converted to an integer immediately. So that's int, then we have input here. So we're going to have, okay, enter your slot number. So we're going to give them guidance here. That's number 1 to 9. Yeah. So we want to collect the input from this user, and okay, let me just have, okay, let's have accept here. So that's if the user does not enter a valid number. Let's say the user enter a letter. Now we want to like undo that error. We don't just want the game to end that way. We want to just print out, please enter a valid number. So we're going to end it like that. So going back here now, all we want to do here is that, then if the choice here is impossible choices, we want to make sure that the choice is still available to make. We want to modify the board. Now you are seeing the use case of this modify board now. Then we want to pass in this choice as a parameter there, and we want to give it the marker of X. So that's how we modify the board. Then that possible choice there, we want to remove that choice we just made. We just picked from the possible choices. So remove choice. Then we want to break this try block error. So yeah. So this is our player's turn, and what is how our player is going to be handling this. So we display the Conant board, we ask the player for a choice, and we check if it is valid. So now after we check if it is valid, now we want to just like, okay, we want to block the import, like we want to block the important ones because it handles cases like, we want to use that try except block is important. We want to make sure we use it because it's very important, and it handles cases where the player enters something that is not a number. So to avoid the code itself from scratching. So I will just go ahead and erase this, and okay, let's try and call this program now. and we'll give it board. Then yes, we're going to have another variable here which we're going to call possible choices. So possible choices here, and this is just going to be a list of every possible slot number 9. So then I'm going to give it possible choices. Okay, so one other thing I would like to do is I would like to point out the possible choices to make us know that yes, this option has been made and we have like picked this option. So possible choices now is okay. Let's just print it out here. So if I should run this again now, we get the board here and we have to pick a slot number. I'm picking slot 2 now. Let me enter. Now see 2 is no longer available in the possible choices and the game's end. So let me make sure that okay, after the possible choices, let's also display the board. So once also display the board, and okay, let me run this. Okay, let's run this 5 times for I in range 5. Okay. Okay. So now to select 2 here, you can see I have this place now. I have the X put here. Okay, I have the X there. So 3 now. Again, you can see I have X here right now. I should select 1 now. I have X throughout all this place, and I can select 9. That's the slot 9. I have this slot modified to the X. I can select 5 here too. You can see we have it like that, and that's all. Now we've run the program 5 times and we have 5 places filled with X like that. So that's how we work with the player stone. So we'll be able to do that now. So let's now like okay, undo when the computer too is making its choice itself. So and what we want to what we want to do is that we want to have a computer choice too, a computer function. I'll say computer, then turn. Then we want to have the board as an argument here also. I want to have possible choices, so that we make sure that they are always picking within the choices itself. They're not picking anyone that is not available in the choice itself. So we have undo. Let me just document this. Undo the computer. Stone. Okay. So now we undo the computer turn here, and what we want to have here is choice equals to. We are going to use a module called random here, and to do that, let me just collapse this now. We are going to go here and we import random. So now that we've successfully imported random, what we want to do is choice equals to random dot random possible choices, and this is just going to pick any random number between these possible choices. And what we want to do after that is just print out this. Okay, I want to make sure this is a new line. That's why I'm using this. I want to say CPU choice as computer choice itself. I want to print out the choice. And what we just simply do is that when we separate some prior arguments in a print function with comma, we are telling us that we are not just only printing out this, we want to print out this also. That's what we are trying to do there. So after that, now we want to modify the board. And you must have guessed now, when we are modifying the board now, we are using the choice of the computer there, and we are also using the marker O and not ours. So we want to remove the possible choice from it also. So possible choice dot remove choice. Okay, so let's just do the way we do with this player here. So let's just print out this board and get the possible choices also. So I'd just like to prompt this to computer choice so we can test this out and see how it works well. Okay, computer turn, that's work quite alright. Okay, random.rounding is possible choice. So there's a typo here. It's meant to be random.choice. And this is to pick between the range of two numbers, maybe 1 and 9. But using random.choice, we are making a choice out of all the elements in a list, and this is a list right from here. So I'll run this again now. So this has been run 5 times, and you can see all the choices that the computer make here. So I should go to the very place here, very first one here. You can see the computer made a choice of 6 here at first, and that 6 was subtracted from here from the possible choices. And we see that on the slot 6 now we have O there, and you can see now when it is 5 on the slot 5 we have O there, and that 5 is no more present in the possible choices here. Same thing as when the computer picks 4, that also was subtracted too from the possible choices on the list, and here we have 1, this was also gone, and the last one was 3, that was gone also. So that's how we want to like have the Tic Tac Toe game to run. So the next function we're going to be having now is just the main game loop itself, because we want to keep on playing this game until one of the players win or the user say is no more playing, the user decides to leave the game. So we want to put everything together, all those functions together in the game, and alternate between the player and the computer mode. So either one of them wins until one of them win the game on the board is full. So that's what we're going to do here now. So we're just going to have def game play game. Yeah. Then we just call this main game loop here. So we have main game loop right here now. Thing is, okay, all these possible choices on this board, we want to have it under this function. So I will get rid of this for now. So we want to have this under this function here, and we want to have another variable here, and this is going to be a local variable. I'm just going to call it turn counter, and it is set to 0 by default. And if you don't know what I mean by local variable is a variable that is defined within the context of a function. Within a function, that's why you can access it. You see that I can't access it here now, but I should try to say turn counter here. It's giving me an error. I should just say plus equal 0. There's a problem here because I'm trying to access it, but if I should just like leave it as a definition of another variable, it's taking this as a new variable, not like this itself. So I can only access this variable within this function, and same as the possible choices and the board itself. So I'm going to say why possible choices. That means why there's still values. There's still a value in that possible choices. I want to take the turn counter here, then and I want to divide it by 2. So I'm dividing it by 2 and I'm getting the remainder, right? So this is the modular sign. I'm using it to get the remainder when it's divided by 2. So when it is divisible by 2, that means when the turn counter is an even number, because even number always divisible by 2, and like the remainder is always 0. So when it's 0, I want the player to be the one playing this game. So I want to call the player turn, and I want to give the player the board and the possible choices he has left. But otherwise, that's else now is the computer turn. So whenever it's not an even number, whenever it is an odd number, we want the computer to be the one to play the game. So I will do that now, and we have possible choices also here. Okay, yeah, we have possible choices here also. So, and at the end of all this code now, right here, let me just say I want to have turn counter plus equal 1. I want to increment that by 1 always. I want to like have an increment of 1 always for that. So that's how it works now. So this while loop is going to continue until there is no more available choices in the possible choices list, until this list is exhausted. is going to keep on going. And we using this turn counter now, we're able to alternate between the player and the computer game itself, just to check whose turn it is. So let's test this out and let's just play game. So if I should play game now, it's my turn as far as even number first. 0 is even number. So if I should pick 1, you can see now the computer has picked 0, right? So if I should pick 5 now, that's okay. Computer has picked the slot 4 also. Then now I'm picking 2. Now see now the computer 2 has picked slot 7. So let's just play this until the game's end. Now you see we are left with just slot 6. And let me pick 6 now. The game has ended because the possible choices list is already empty, and all the values here are already exhausted. But we can see now that X won the game because X has diagonal line here, and we are not able to detect whether the game has ended based on a user winning the game. You can see right from here before the game has been won, even right from here I've won the game here. But we're not able to detect whether the player or the computer has won the game. So we need another function to do that. And how do we do this now? We're just going to have a function here, and I would like to have it between this computer's turn and the play game itself. I'm going to call it def check for winner. So we are checking for winner right now, and we are going to have it as a board here. So I'll just document this and just say check if there is a winner and return the winner or not. So we're working with this now. So what we want to just do here is that we want to check the row. Just like, let me bring that. I want to check each row like this. If it is the same character that is there, then diagonal 2, just like the Tic Tac Toe games. We'll get there again. I want to check the rows, the columns, and the diagonals. If we have the same marker there, then whenever the markers in a row or in a column are the same, we want to say that marker is like the owner of that person using that marker is the winner there. And by default, our player is using the X marker while the computer is using the O marker, letter O marker. So for winning combination, we are just checking for winning combination right here. So how do we do that exactly? We are going to be looping through the rows for I in range rows. So we have rows here, and if you are wondering where rows is coming from, rows is coming from this constant we defined right here. That's I in range rows. So we are looping through that 3 times now, and now I want to check if board I 0 equals to board I 0 equals to board I 0. This should be 1 I1, then I2. What I just doing is that we are looping through this, so we are going to be getting, first time we're going to go through this loop is going to be 0. So this will be 0 0 0. Then the second time it will be 1 0 1 1 1 2. Third time will now be 2 0 2 1 2 2. So that's just like us going through this, like 0 1. This is 0 1 0 2 0 3. Then 2 0. This is just us looping through this, looping through each row. So this function just loop through each row like this. So let me just comment this there. Loop through each row for a winning combination. So we do that, and now if any of the row are having the same marker there, we just want to return the row itself. We want to return the full row itself. We just want to return a combination there. Just one of the combination, just like not the full row. Let's just return one of the combination there. So, and we also want to check something related to this, but in this one we'll be checking the column instead. Okay. So now this time around, this will be 0, this will be 0, and this will be I. Then this will be 0 to B. This will be 1, and this will be I. And this will be 2, and this will be I. Then we're looking through each column here. Let's put it this way. Each column here for a winning combination. So at any instance, if there's a winning combination here, we just want to return that combination there. So this is just like a very easy way to look through this and to check this out here. So after looking through that now, we want to check for diagonal winnings. So to check for diagonal winnings is just like we're going to check if board, because there's 2 ways to win diagonally, and that's just like 1, 5, and 9, then 2, 5, and 7. So I'm just going to check that now. So 0, 0 equals 2. Let me just try and paste this. Okay. If, then I just change this to 0. And let me have a comment up here. So I just say our diagonals winning combination. So we have it this way. So by any means, if we have the winning combination to be like any of the game to be won diagonally, we want to return that one of the marker there. So I'm just going to have return here that, and okay, let's just copy this now. And let's work the other way around. So we're going to be having okay, this is 0, 0, 1, 1, and this should be 2, 2. So that was just like okay, this is 0, 0, this is 1, 1, this is 2, 2. So now this will be 0, 2, right? Then 1, 1, then 2, 0. So that's 0, 2, 0, 2, 1, 1, then 2, 0, 2, 0. I want to return just one of these. Okay, let's just return okay 0, 2. That's fine by me. Oh no. Then otherwise, if we are not returning anything in any of these, let's just return none. So we want to just make sure okay, we return none in this case. So now we want to be able to check for winner, and we have to be able to check for winner here, and we are just returning a single marker, either X or O, if the winning combination, if any of the condition for the winning combination is true, we are returning just a single combination there. So now we'll now modify our play game function now to get a winner, and what we're going to do here is just okay, right here. So after this while statement here, we have winner, we have a variable called winner here, and we call check, we send it to check for winner, then we give it the board. So if winner now, if you are getting anything other than none, we want to display the board. want to display the board here and just return the winner. Okay, and return the winner to know, okay, X won the game or O won the game. Then else here, we want to just make sure we're always returning none. So we want to make sure we're always returning none. So we could just, okay, let's try and run this game again now and see. So let's pick a slot number here. Okay, nothing else. Let me try and win this game. Okay, all luckily blocked me. So let me go for slot 3 and slot 7. So now you see that yes, we have a winner and the game was, we're out of the game because we have a winner already. So let's just wrap this up with the last set of code we are going to be having here, the last block of code. So just wrap this up, and so we can track the scores also. So let's have it run so we can track the scores and build the last part of this code here. So I'll just erase this for now. What I'm going to be having here, let's just use if this name equals to main. If name equals to main, I want to have x score. I want to be able to track the score, and by default we set the scores to 0. Okay, then I want to have also y score. Set this to 0 by default. Then y true, we want to always run this game. Y true, winner is equals to play game. But we are returning something from the winner, so we want to get the winner of the game always whenever we play the game. So this is like each round of the game we want to get the winner. Then if the winner here is equals to x, we want to increase the score of x here plus equal 1. I want to print out, okay, let's put this on a new line, you won. So we want to print this out like this. Then else, that's elif winner equals to O. I want to increase the score of O plus equal 1. I want to print out you lost. Oh, okay, we have S score and we have O score, not Y score. O score, yes, you lost. Then otherwise, we just want to keep on playing the game. It's better, it's a tie. And let's have it a tie. Okay, let's have it on a new line also. And since I'll be using a single quotation, a single quote there, I should start with double quote. A tie. So I have it this way now, it's a tie. And at the end of all this, we want to always print out the score itself. So I'm going to say current score u as x. I want to have x score then let's have the CPU or the computer, whatever you want you can call it, that's O. That's O. Let's have it as, okay, O score Okay, I want to print out the score always there. I want to have a replay also. So in case the player wants to replay this game, we will just say replay is equals to input. Do you want to play again? So this I want to play again, and just say y/no. So let's just strip this, and this is to make sure that every white spaces are removed from the input. I want to convert this to lowercase. So whenever replay is not equals to y, we want to quit this game. I'll just say thank you for playing. Okay, just say thanks for playing. Okay, sorry, this should be in quotation. Then want to break out of this program itself. So we can run our beautiful Tic Tac Toe game now and start playing. So I'll just play this one now. You can see. Okay, computer has played this game too. 4. Wow. Kind of taking a toll on me. Okay, time to win this. I won. So I'm having 1, the computer is having 0. So, do I want to play again? Yes, I want to play again. So, playing again, another round with the computer. 2. Okay, 5 and 8. I won again. So that's 2 for me. I want to play again. And now let's try and let's see if I can lose for the computer itself. Okay. Okay, I lost. And now the game is 2-1. So anytime I enter anything that is not like yes, that's why I'm out of the game. Thanks for playing. So that's it. We've built a functioning Tic Tac Toe game in Python. You can play against the computer and you can keep track of your scores. I hope you learned something new today. If you have any question or unique clarification, drop it in the comment section or the chat section there. Feel free to drop them there. And if you want to build the GUI version of this Tic Tac Toe game, I have a link to my GUI tutorial on Tic Tac Toe Game with Tkinter down in the description below. You can click there to check it out. Thank you. See you next time.